Good morning, folks.
How's it going?
We are here at Orange Vise with Eric. We are going to get to see some awesome machines and walk through. Let's take a look at how you make the Vise body. That work?
Sounds good.
Kind of flow through the process there?
Sure.
Sweet, folks. This is awesome. One of the things I really like about Eric is not only the products that he makes, but he does some incredible videos. Card here to the series they did on some different factory tours, including one at Durabar.
Exactly.
Awesome.
Yep. So this pallet here, you can see some completed, roughed out Vise bodies.
Yep.
So this is what they look like in between, first off roughing and heat treating. So these are off the heat treating.
Okay. So they come in as a solid. Is it Durabar? They call it continuous cast.
Yeah, it's continuous cast because from a visual standpoint, it almost looks like it's extruded.
So it's never, is it poured and it solidifies as it goes down?
Yeah, so there's a ladle where it's in a molten state.
Yep.
And it basically flows through a graphite die.
Okay.
And the graphite die is water cooled. So it immediately solidifies on its skin, but the inside is still liquid.
Yep.
And then as it passes through, it cools over a continuous line.
Yeah.
And the line is something like 75 to 100 feet long.
Yeah.
And it doesn't get cut off until it's down to about, I think, 60 to 75 feet.
Wow.
This is our Op1 machine. It's a Doosan Dnm 750L.
Okay.
The L is an extended X-axis offset, X-axis capacity. So it's an 84 by 30.
84 by 30?
Exactly. So
and
it's a
50 taper?
It's a 50 taper.
Wow.
So it's a linear weigh machine. I think they're roller guides.
Okay.
And so it has a pretty decent rapid speed.
Yep.
Pretty decent feed rate.
Yep.
At least for a machine this big.
Yeah.
And it's a full 7-foot long table.
Yeah, that's insane.
Yeah. So yeah, right now we're just machining some of the smaller parts. No bodies being machined in here, really because of the noise level.
Okay.
It'd be pretty difficult to.
Is that the Maritool chamfer tool? Is that Maritool chamfer? Yeah, I know that tool. That's funny. Yeah, so we use this because it uses the same insert as the Tormach Superfly, like an SHMT or something.
Yep.
Huh.
Yeah, this exact operation used to be done in one of our horizontals.
Okay.
Where we would actually rotate the part and just hit it with a face mill.
Okay, sure.
And that was actually quite a bit faster, but ultimately it's, the horizontals are overloaded.
Yep.
And we have some capacity in the vertical.
Yep.
And the reason why we went with a vertical to begin with was kind of twofold. One was just the loading and unloading of heavy Vise bodies. They're about 120 pounds for the 20-inch in a raw state.
Yep.
So trying to get that sideways and then up, essentially above your head, was kind of a safety hazard. We do have some aggressive tool paths, but for the most part, our parameters are a little bit on the conservative side, and that's really because of process reliability.
Yep.
Our newest horizontal, which we'll see in a second, has about 2,000 hours racked up on it in the first 4.5 months. So, and we fully expect it. It's really we actually have a hard time keeping it fed. So if we were to basically just have a swing shift, we can keep that thing running, almost 24 hours a day.
Yeah.
So it wouldn't be surprising if next year we actually break 7,000 hours on that machine.
Wow.
Yeah. So this is the first stop of our carrier slides.
Oh, sure.
Yeah.
Okay. Wow, there's a lot of material. On that thing.
Exactly.
Holy cow.
And these are cast iron.
Okay.
And the reason we like to use cast iron is the same reason why we use them for the bodies is because of the graphite content and the stability. Because they are a sliding mechanism.
Yep.
And not only is it sliding, but there's a screw thread in there. It's constantly going in and out under very high forces. So we actually use the remnants from the bodies. The bars start out 6 feet long.
Yeah.
So if we're cutting 3 20-inch parts, we have a foot left over.
Sure. That works out here.
Exactly.
Lean.
Yeah, exactly.
And the fixturing here, so you've got some soft jaws in orange bodies right here.
Right,
looks
exactly.
like. And then this is fixturing for doing
for
actual
bodies. Yeah.
Sure. And these are just pit bulls.
Yeah, these are pit bulls.
Yeah. Very cool.
Yeah.
I can't believe how large that starts out at.
Yep.
Okay, and here's a chunk. Wow, yeah, I can see why you don't want to lift those up.
Right.
So the way this works is you've got looks like a large plate, and you can actually use an overhead to load this whole thing on.
Exactly.
Wow. So there are eyelets that come in or something?
Say again?
Eyelets that lift points?
Yeah, there are half 13 threaded holes.
Yeah.
So we just put on some hoist rings,
Yeah.
and then we can replace that whole thing with magnetic milling chucks, which is what we use for all our subplates.
Oh.
Yeah. So
Very cool.
So the same chucks that we use on our grinder, we actually have 2 more of those.
Really?
That we have. Basically, we bought this machine kind of to complement the grinder.
Interesting.
When we were deciding on which grinder to get, we were originally thinking about multiple small ones, but we ultimately decided on one big one because we were thinking for a small one to be productive, we would need automation.
Yep. Yeah.
But automation is something that has a pretty steep learning curve, especially in a grinding process, because it's not as simple as putting it to a vise.
Yep.
Because magnetic chucks and all that stuff, and then just the type of controls that grinders have aren't really. It's not so much. There aren't a lot of turnkeys available for that.
Really?
So there's a lot of engineering involved in getting a grinder to be automated. So that's something we want to do eventually.
Yeah, sure.
But at the moment, we figured it's going to kind of be a brute force thing for the first year or two, and we decided to go with a really big grinder. And so what better to complement a big grinder with a big vertical so that we can make subplates up to 7 feet long.
So you can grind, the grinder is amazing, folks. You can take stuff off this and grind. What's the travel on the grinder then?
The grinder is slightly shorter, it's 80 inches.
Okay, so 4 inches shorter.
Yeah, so it's 80 by 32, whereas this is 84 by 30. So there's a slight mismatch, but it's close enough. Essentially, we can go up to a VF7 in terms of a full table subplate.
Right. Amazing.
Yep.
Wow.
So this is our NHX 6300. It's a 630 millimeter horizontal.
So that refers to the travel.
630 millimeter. So on horizontals, they always go by the pallet size.
Okay.
So 630 is roughly 24.8 inches square.
Of the vertical tombstone.
Yeah.
Okay.
The travels are roughly 3 feet cubed.
Wow. Okay,
Yeah.
that's a pretty good machine.
Yeah, the swing on that is, you got to kind of look at it corner to corner. And the swing on this is about 3 feet.
Wow. Also a 50 taper.
Also a 50 taper.
And this is the machine you just mentioned that's new, or
relatively new. We got it at the end of 2015.
okay.
So.
Wow. Look at that. So tombstone, I can obviously see the ball locks to mount a body. Oh, there's a Vise body on it.
Yep.
Right there, huh?
We can actually run this in a second.
So the cool thing about a horizontal, there's a lot of benefits, which to me weren't obvious at first, including chip control, the rigidity of the machine. This machine can support tombstones, so they can load this here sort of offline. So if you know what you're doing, you should really be able to have, I don't want to call it 100% spindle time, but darn close.
It really depends on the type of work you're doing.
Okay.
So for us, because we're machining, the easiest cut material we really machine in this machine would typically be, steels in their annealed state.
Yep.
So which is still not necessarily lightning fast.
Yeah.
And then a lot of hardened materials. So that favors us on a 2-pallet machine because the cycle times cumulatively over many parts ends up being pretty long.
Yeah, sure.
So we're not constantly, having people, frantically changing parts just to keep it running.
Yep.
So depending on which cycles we're running, we can have this running, 15 to 16 hours straight without any operator attendance.
You can.
Yeah.
That's amazing.
So,
wow.
So to get it to run at that level is really about really good process reliability.
Yep.
So process reliability is a combination of reliable tool paths.
Yep.
So that your tools aren't either not just not breaking but also not wearing out and creating undersized features.
Sure.
But also chip control and stuff like that.
Yeah, right. Chip evacuation, not by,
like we've done some high-speed tool paths where they would fling the chips right into the corner of the machine to where the way covers would kind of crunch up. So we learned the hard way that we should have kept the shower coolant on 24/7. But that's goes to another point about process reliability is also keeping our coolant levels up. Because right now here in SoCal, especially in northern Orange County, today is a 94-degree day.
Yeah.
So on some of these machines, we can lose about 50 gallons of coolant in 24 to 48 hours.
50 gallons?
50 gallons. And I mean, that includes the carry-off.
Sure.
But a lot of it also just includes, you can imagine how much evaporation you get from, 3 or 4 coolant pumps going on at the same time. Because the chip conveyor itself on the horizontals is a drum filter type. which is powered by coolant for.
Oh, really?
Yeah.
Interesting.
There's a constant coolant spray in the filter.
Yep.
And the actual conveyor where there's scrapers is only a few feet long.
Huh.
Rest of it's all coolant.
Wow.
So it's constantly spraying coolant. There's like mist, so there's a lot of.
We've noticed that too with when we blow coolant on a face mill or through spindle coolant drill. It just you lose a lot.
Right.
To
exactly.
Atomized coolant.
Right.
I complain about losing like 3 gallons a day.
Right.
But then check this out. Holy cow! Are you serious, Eric? This is insane. I can walk. I can walk inside the tool changer. I am inside the tool changer right now. It's interesting that they keep it with a large ring. I feel like when you get this big, you see the double backed, the roping bands.
Right. The 60 tool changer, the 60 ATC is kind of their standard.
Okay.
And then they stick to the ring type. It's actually the fastest.
Oh, really?
The next size up is a 120, and that's I'm not sure exactly how they do it on the 50 taper, but we got a 120 here on the on the 4000. It's a double chain type.
Okay. You happy with this though?
Yeah, I mean this is very reliable.
Yep.
The only issues we've had with this machine are some sensors, some like limit switches that need to be adjusted and stuff like that.
Got it.
And part of it may have been due to the transportation. It actually got moved twice. Once from Davis to Northern California, another time from Northern California down to Southern California.
Got it. And you were saying this is the, to me, new, but the CLOS controller?
Right.
So totally different interface than what you're traditionally used to?
It's really well suited for production environments.
Okay.
Because you can see all the relevant information on 1 or 2 screens.
Yeah, it's a modern, it's what you think of when you look at how we manage apps. We live in a world with apps and data at our fingertips. Yeah, they're cool.
So here's just a quick snapshot of the tools. We have every single tool is set to basically a timer, and it tracks actual usage based on whatever our experience is. It's not arbitrary. It's actually real time, and then we basically record like statistics over time and see like.
It goes back to the process control.
Exactly.
Making good parts and got it.
So anything that's red here, we swap out.
Yep.
And we can put redundant toolings in here so that once it reaches the tool life maximum, it'll actually switch to the next redundant tool.
So yeah, so you can run lights out and just know in the morning I've got to swap that out. That's cool.
And of course there's caveats there.
Yeah.
We understand that it would be, let's say we had a 330 tool ATC, which is the largest one they make.
Wow.
You have to be very careful in a production environment with, let's say, multiple employees not to put in all these redundants and just, let the machine just go over every single redundant such that at the end of the month, somebody has to change 330 tools. And the machine is down for, however many days trying to change that many tools.
That's funny.
Exactly. So
it's a weird, oddly good problem to have.
Right.
I mean, yeah. Huh.
So we try to. So some of these tools they'll last. Let's say they have like a 600-minute tool life, and in order to exhaust 600 minutes, it takes 2 weeks.
Yeah.
We won't even bother putting a redundant in there.
Oh, really?
And in fact, if anything that's over like a week or two, we won't even have a redundant on the tool cart.
Wow.
Because otherwise, it just becomes kind of a sorting nightmare.
Yeah.
And then because people will look at a tool weeks down the road and be like, what is this?
Right.
What machine is this for? Because the Doosan and the Mori use different pull studs. Sometimes you're not careful about it. The Mori has sensors in the drawbar, so it knows if you put in the wrong pull stud, but the Doosan does not.
That's bad.
Actually, a lot of machines don't.
Yeah.
So that could, it may not necessarily cause an accident, but it could put wear and tear on the gripper.
Yeah.
So that's kind of just things to, if a tool needs to be changed like daily, then redundants are definitely in order. But otherwise, try to keep things simple.
Is tooling cost a big deal to you? I mean, is that something you think about?
Cumulatively, it is a kind of a big deal because we're finding ourselves ordering extra tools. Like before we'd buy enough for one order of tools, it would last us a month, 2 months. Now we're finding ourselves ordering every 2 or 3 days.
Wow.
So now our quantities have to increase such that because we really don't want to manage that much paperwork or logistics of trying to order tools on that frequently.
Right.
At the same time, cash flow is always a consideration.
Yeah.
So we try to keep it weekly or bi-weekly.
Right.
It tends to be kind of a sweet spot.
Cool.
So
there's a Vise body on that tombstone?
There's actually 3 of them right now.
Okay. Renishaw probe. A card here too, if you've seen Eric's the Orange Vise promotional video where they do some pretty cool stuff. I think it's actually a Heimer tip, but oh my god, that machine is fast.
Yep.
Holy cow.
They don't slow down the rapids on their big machines. It's the same 2200 IPM rapids on the little ones.
2200 inches a minute? Wow. Are you running it dry? Do you always run it dry?
Yeah, all of our, basically our internal sort of limit is about 300 to 400 surface feet.
Okay.
Between wet and dry.
Interesting.
So
you will, so some Durabar does get cut wet?
Yeah.
Okay.
So certain operations like T-slotting, any sort of drilling, thread milling, chamfering, we do it wet.
So the obvious advantage as well to a horizontal in the tombstone nature is you've got a de facto, access to 3 sides of the part here. So we'll, I'm sure, be able to machine the 2 sides as well as the face. Is that correct?
Right. And that's really how we keep everything nice and square.
Right.
Not only on these parts, but pretty much all the jaws.
And you can see, it's interesting, even though this is a type of cast iron, can you see the chips? It's not what you think of like a traditional cast iron chip. I mean, it's a real Caesar 6s type of thing, which is cool. And you said it's kind of like you said like a 4140 in terms of the machine, the characteristic of the steel.
Yeah, it's pretty similar to steel.
Choke up on your tools. I like it. Are you slotting?
Yep.
Oh my god. That is insane.
Yeah, these are certain operations that used to be high-speed tool paths, but when we went to a 50 taper, we just ended up burying the end mill, and the tool life is just as good and cycle time is faster. So
that's like a 90% step over right now. Yep. Wow. Do you kind of have your tooling locked down, or are you always thinking about trying new tools and experimenting, and where can you find
we always, basically when we spit out our setup sheets, which gives us our kind of time and cut for each operation, we always go for the lowest hanging fruit.
Okay, sure.
And I mean, there's certain operations where we're pretty much always tweaking, but not on every tool.
I've asked for that we use Fusion 360, and I think you mentioned you use some of the you use HSM Works some.
Yep.
And I want we need this, a way where you can output not in the setup sheet, but rather in your cam operations. Just show me all the machining times for each setups, because I want to go look too. If I've got the lowest hanging fruit, what takes the longest has the most chance for improvement.
Keyboard kind of slides up and down with all your standard.
It's just so different. I don't, it may not be a bad thing. It's just so different.
Yeah, it takes some getting used to.
There's options though on the Silos too. Like there's 2 or 3 different versions of it.
I think it depends on like his 5-axis. I'm sure it has its own set of features. So we're basically using our own vises to machine the jaws for our vises.
It's like a 3D printer making a 3D printer, but way cooler.
Exactly. And yeah, we've been kind of overloaded for the last few years. Every time we grow a little bit, the demand grows accordingly.
Yep.
So we always ended up with seconds for our own personal use.
That's funny.
So these are all the ones that are slightly off.
Yep.
This was a failed black oxiding experiment, and
it's
red instead of black.
Huh.
and then all of them are trimmed down to clear the jaws, so that we're not digging the chamfer tool into the Vise body.
Right.
But
cool. So this is a smaller, but still quite large Mori horizontal.
Exactly. So this is the NHX 4000, 400 millimeter horizontal pallet size. And this is very similar to the one we started with that a lot of people are probably familiar with.
Yeah.
But this is just the next generation one. We bought it mainly because we wanted the pallet pool, and we just didn't have room for the old one.
Pallet pool meaning you've got multiple pallets. I see.
Exactly. This allows 5 pallets to run, or 5 pallets to run basically sequentially. You can actually add a 6th pallet, but because there's actually 7 spots. The way the pallet manager works is that they do require 2 spots to be empty to run continuous operation. That said, you can have 1 pallet set as a dummy with no program attached to it, and so you can have 6 pallets in there, but in a continuous operation you can only run 5.
So if you were to put in 5 pallets and each pallet had different work parts on it, you just tell Silos pallet 1 has this program, pallet 2 has this program?
Exactly. You basically just click on one.
Yeah. Oh yeah.
And this is running 4.5-inch master jaws. Any given time you can actually, if you had redundant tombstones, or let's say kind of a universal fixture that runs different parts, you can set 2 to running the same thing, or whatever. So that can be beneficial if you have 1 part that has a longer cycle time, and then you can run that one at night.
Yep.
Rather than have something finish at 1 a.m. and have it sit for the next 6 hours.
Sure. So. And otherwise, similar horizontal machine, 40 taper.
So this is some people who follow our Instagram may have noticed more recently we've been modifying tombstones for customers.
Okay.
And we've been really liking the ones from Tombstone City. They're made in Taiwan, but we modify them here. Out of all the cast iron tombstones, these have been the most consistent for us. We've tried a lot of different manufacturers, and these seem to be kind of the best balance between quality and price.
Yeah.
So
a lot of money tied up in work holding a tombstone.
Right.
So you're making a commitment to
exactly.
Yeah, right.
And we're also carrying inventory now for tombstones for other customers.
Oh, interesting.
Yeah.
Very cool.
So.
Awesome. So this is going to do some of the sort of smaller work, like
this is all the jaws and all that stuff, and that includes masters, any sort of jaw plates, aluminum jaws as well.
Okay.
Because this is a 15,000 RPM spindle, whereas the 50 taper is an 8,000 RPM spindle.
So you'll run steel, cast, and aluminum in one machine.
Exactly.
Sounds like fun.
Yeah, exactly. I mean, it's pretty dirty, but when we switched coolants to Qualichem.
Yeah, I saw the 250C.
And yeah, exactly. And that was actually pretty beneficial for us because the cast iron dust stayed in suspension, which means it gets carried off with the coolant.
And then you can filter it.
So, well, a lot of times we just let it stick to the chips and recycle.
Got it.
And there is a cost associated with the coolant replenishment.
Yep.
But at the same time, it reduces some of the coolant disposal costs.
Yes.
Because the coolant recycling company is taking care of that. And
so you send out Qualichem and they send you back clean Qualichem?
No, we send the chips for recycling.
I'm sorry, gotcha.
So yeah, they have their own sort of environmental procedures to make sure they're not violating any EPA standards.
Sure. You can't. We're learning this as well. I mean, we've never poured Qualichem down the drain, but now that we're evaporating, going through more, we have a safety clean that comes and picks it up. So you gotta play by the rules on that.
Exactly.
Stuff. Yeah. Okay, so what's next?
So the ATC that you on this one is a 120.
Okay.
And it's a double belt type.
Eric, this is so cool.
And
oh my God.
When we originally were informed that, all right, this is a double belt type, we were like, all right, great, well, whatever that is, all I care is the number.
Yeah, right.
Interesting about this one, it has, it's got transfer slots in between the 2 belts.
So they're independent belts?
Yeah, independent belts, and then transfer slots from the first belt to the arm.
Yeah.
And this is actually sort of like a carousel type ATC.
Yeah,
where the tools are resident to their pockets. They always go back to the same pocket.
But it stages the tool.
You can still stage tools because it has those transfer slots.
Yes.
But that's what's interesting about this.
Right, so the Heimer is always going to be in whatever number that is.
Exactly.
Okay. That has its benefits.
Yeah. So what's really cool about this ATC compared to the ring type is that this one has its own control panel. So I can actually call tools by number from this panel.
While the machine's running?
While the machine's running.
Oh, it's amazing. So you can do tool swaps.
Exactly. When the door's open, then once it gets to the next tool change, obviously it won't do it.
Okay.
But if I'm...
okay, because the tool change happens somewhere through there. Oh, right here. Oh, literally the tool change happens. This is the tool panel right here.
It's actually behind there a little bit.
Oh, interesting. Yeah, there's a row up there.
So.
Okay. Wow. Incredible. When we did the Haas factory tour, they had some bridge mills that had the S-shaped slinking, and I don't know what they were, 200, 300 tools, just insane.
Yep. So I got our tool carts here.
Look at all the tools. So all looks like 50 tape, bro. There's some 40 tape.
50s and 40s.
Yep.
All sorts.
Amazing.
This is our brother M140X1. It's a 4+1.
Okay.
It's
4+1.
Yes, 4+1 because it has a trunnion.
Oh.
It won't do full fifth, but it'll do 3+2 and 4+1.
Very cool.
Yeah, I think brother's reasoning for not doing full fifth is because of export laws. Getting to 5-axis is restricted. Is a lot more restricted due to potential use for weapons manufacturing.
And I've heard that some of these machines, if you relocate them,
both our Moris have that.
Really?
And,
so when you move, you've got to call.
Yep.
They need to approve again. So the idea is you can't sell this to
exactly
North Korea or something.
Yeah. Previously, they used to have to call Japan.
Wow.
And the time zone difference caused some problems.
Yeah.
But now with Davis online,
okay,
it's a lot better. They can usually get a code, like a passcode up in like 5-10 minutes.
Yeah. Oh wow, interesting. Okay, so it's got a double knuckled, or what do you call that? Yeah. So that's your. Oh wow, it really is a.
Yeah.
Okay.
So the trunnion is the A-axis.
Yep.
The chuck is the C-axis, and obviously you got X, Y, Z on the table.
And this is your typical brother, just crazy fast.
Right.
Yeah.
Exactly.
But what's amazing, you said this can be, because it can do a type of mill turning. It can turn
it does turning.
What's the RPM on the chuck, do you know?
The chuck is 2,000.
2,000?
Yeah. And then the spindle is 16,000.
But can you hold a lathe type tool in the
basically
VT30?
These two pins right here are basically used to hold the turning tools.
Really?
So let me see if I can index that.
Yeah, sure. And you use it as that.
Right, exactly. It's got its limitations.
Yep.
Number one's obviously a torque limitation, but more importantly, it's a chip limitation. Bird's nests don't do as well on this type of machine than on a lathe where everything falls off.
I've had great experience making bird's nests on lathes. Yeah, so this part, which is a lathe part, is coming off that machine. That's cool. Even got a little robot. And there's the little tool.
So basically here we've got a little CCMT boring tool from Mori Tool.
Yeah.
Inside a Lindex Nikken holder.
Wow.
It's basically just a standard BT30 holder that has a flange.
A flange on it, and it just rests against those two pins.
Yep.
Really?
And this will repeat just like a lathe.
Yeah.
If not better in some ways, because a lot of our turning is done in a vertical position, kind of like a vertical lathe. It's immune to Z-axis growth on diameter.
Oh, did you hear that, John Grimsmo? Yeah, no, that's amazing. Wow.
So, I mean, it'll rough turn, but like I said, because of the torque limitations and all that stuff, it's always better to do as much milling as you can and kind of finish with the.
So you could interpolate and then get your finish tolerance, etc. Sure.
And then on this type of machine with so much going on, you want to keep your chips as small as possible.
Okay.
So using corn cob end mills or any sort of interrupted fluid end mills is always a good idea.
Yeah, we were just playing around with the Lakeshore Taz, and it was this new roughing tool, and it's it's awesome.
Yep,
tiny little chip, consistently small chips.
And it's not just because of the size of the chips, but the bigger the chips are, the more they nest together.
Yeah.
Especially as they start curling.
Yeah. So. Well, it makes a difference when you're exporting or when you're shipping out chips for recycling.
Right.
The more I can fit into a drum, the better off.
So yeah, this one is robotic fed. It is a bit of a learning curve to this one, just because machining stainless steel parts, they do leave burrs when we saw cut them, so we got to kind of account for any sort of burrs that are on there, where it might have to be a little bit deburring beforehand too.
Got it.
And just, but for the most part, the equipment itself is reliable.
Yep.
It's all the variables.
So a hydraulic chuck that can open and close, so it's just the robot does the transfer through. Cool.
It's similar to your standard lathe hydraulic chuck, except rather than having a big draw tube, it's just a small one, because obviously you're not going to do any through bar work on something that has a trunnion.
Right.
So,
and folks, take a look at this. Gosh, if you guys don't follow Orange on Instagram, we'll put a link in the video description. But I think you posted a photo of this when it was maybe getting unloaded or something.
Yeah.
Just amazing. You want to explain to us what it is?
Yeah, so this is a surface grinder. Double column, so you get a lot of rigidity and no flex as it moves to different parts of the travel. But this is just basically what we use for all of our grinding now. Yeah, we're originally looking at smaller variations of same grinder from Okamoto, but we decided to go big just because of we know the complexity of automation would make it would push it back in the timeline. So something that would work for us in the short term would just be basically loading a ton of vises on here at once.
And so that's what this is. This is so fun. It's so peculiar looking to me. You know, it's weird to see a bridge style grinder.
Right.
But there's your wheel, folks. It's a 20-inch by 4-inch, 20-inch diameter, 4-inch wide wheel. Look at that. And these hockey pucks are part of the magnetic chuck for the hold down.
Yeah, we ended up going with the magnetic or a magnetic milling chuck rather than your standard magnetic grinding chuck.
Okay.
And that was for a few reasons. Number one was the ability to basically change, because these pole extensions are just 1018 steel.
Okay.
And they're removable.
Yep.
So we can customize those to our liking in the short term by basically creating gaps and stuff like that. For example, if we're grinding the tops of one of our jaws, rather than putting them on magnetic parallels, we can actually just slide it right here.
Sure.
Right.
Well, and that becomes a consumable. It's cheaper to, I assume, replace some 1018 than a whole magnetic chuck.
Exactly, because a whole magnetic chuck is about $50,000 for
50,000?
About $50,000 for a pair of them to cover this table.
Wow.
Whereas,
so we've got a 16 by 32 Okamoto. You guys have seen it in our videos, and a new chuck for that is like $7 grand. Right. 50 grand. Wow.
Exactly. And more importantly, though, is we do anticipate automation on the loading and unloading.
Yep.
And that's where, by having a lot of flexibility in here, we can start plumbing air and coolant into the chuck for automated cleaning, automated ejection. Because obviously there's surface tension here. As you know, every time you try to pull off a part, especially after you flip it on the ground surface, it's really difficult to pull it off. So,
so you need ejector pins on an
either ejector pins or even just air. By creating, by blowing air through every single pocket, it's just gonna float up, kind of like a air hockey table or something like that. So
this is the bread and butter. At least these are we've got on our Haas VM3. These are 6-inch by 20-inch double station orange vices. Is that right?
Yep.
Cool.
Exactly.
So you grind. What sides would get ground on this?
The sides first, and then top and bottom. So we grind four sides.
All four sides.
All four sides.
Okay. Look at that move. Oh. Yeah. Oh, is it going to dress?
Yeah, it's going to do a diamond dress right now.
Wow.
So the machine comes standard with both diamond and table dress.
Okay.
The diamond dress is an overhead. The drawback to that is really that you don't know how parallel it is to the table.
Yep.
I'm sure Okamoto does a very good job at it, so it's probably about the same.
Yep.
But it's that unknown uncertainty.
Yep.
And so we prefer sticking with the table dress.
Do you sacrifice some machine travel though by having it mounted?
Yeah, we basically, that corner there, you
Yeah.
can see the pole extensions are removed.
Got it.
And that's to prevent anyone from accidentally putting a part there.
Yep.
But yeah, it's auto compensating. So it just took off a thou on radius times 2, so it took off 4 thou. So now the diameter got shrunk by 4 thou.
Yep.
And it compensates.
And it now knows your Z height is
Exactly.
changed. Amazing. Amazing. And then here it goes, huh?
Yep. So right now we only got 4 loaded.
Yep.
Normally we try to keep it around 8.
Yep.
That's kind of our daily goal is to do 8 at a time.
Yep.
The reason why we're only doing 4 at a time, because this time we got to mix between 4.5s
Got it.
and 6s. So obviously different heights.
Different heights. Yep.
I
Do you
mean,
know is it hydraulic?
Yeah, it's hydraulic.
Okay, so just literally a huge version of a smaller grinder.
Right, exactly.
Wow.
All the concepts behind the machine design are the same.
Go.
You notice that cable coming out the middle of the grinding wheel. That's the
Yep.
auto balancer.
What?
Yeah.
No.
We don't balance our wheels anymore.
Stop. How does that work?
The wheel hubs actually come with the little balancing weights.
No.
We basically toss them in a Ziploc bag, never to be seen again.
No.
And you can see right here.
No. It's like we've seen this in trade shows before that have like, well, you still have to, like the Heimer has a balancing machine, but you still, it
Right.
tells you where to put the weight.
Exactly.
This just does it,
Yeah, because the weights are built in.
and it can move the weight position.
Yeah, it's
That's
dynamic.
Insane.
Yep. So right now you can see on the balancer it says it's we're off basically by 0.2 microns.
0.2 microns. Oh
Yeah.
my God. 1,000 RPMs on the wheel, huh?
Yep.
And so when you're grinding both to flatness, squareness, but also to a nominal?
Yeah.
Okay.
On the sides we it's more, well we're working on the size to a nominal, but it's a little bit less important.
Yep.
On the final face, which
Yep.
is always the top face,
Yep.
we grind that to a nominal of 3 inches.
Okay.
And we like to keep in round numbers. That's why we chose 3
Yep.
rather than like 3 1/8 or 3 62 and a half hours, stuff like that. But in the end, the flatness is still the most important.
Mm-hmm.
If it's slightly off in nominal, we'll just let, they might either be a second or we might regrind it.
Yeah.
But we won't ship anything that isn't flat to spec.
Yep.
So this is our NLX 2500 live tool, the sub-spindle lathe. A lot of folks have probably seen this before since we've had it since 2013.
Okay.
No, 2014 actually.
Yep.
It's actually a very popular machine, probably one of the most popular machines on the Mori side.
Yep.
And it really hasn't changed mechanically in 10 years or more than 10 years. So
Boxway on the. Yeah, that's Boxway, right?
yeah, it's Boxway.
Yeah, that's huge.
Yep.
It's got to be incredibly rigid, huh?
Yeah, it's very rigid. And we can. The limitation is almost always in the work holding.
Okay.
So if we're hogging off a lot of material, it's we just got to make sure the chuck is grabbing onto enough material. Like I've done some jobs where we're holding onto 6 to 8 inch blanks.
Yep.
Stuff where I had to step inside the machine to hold, and it was only grabbing onto about about half an inch, 3/4 of an inch.
Wow.
And I've actually had a piece fall, dented the weight cover.
Yeah.
Actually, it fell twice onto the same spot. It was the same part. I guess I didn't learn my lesson.
Yeah.
But machine didn't really care, just kept going.
Kept going.
But it'll take a 200 thou depth of cut using like a CNMG 433 at 15 to 20 thou per rev.
Oh my
So
God.
the machine this will machine all day long.
Yeah.
So like if you compare this machine to the brother,
Yep.
this is really like a full-on lathe with maybe 33% milling capability, whereas the brother is all the milling capability you'd expect out of a 30 taper brother. All the speed and all the high speed milling capability, but the turning would probably be about 30% of the lathe.
Yeah,
So
that
it's
makes
kind of flip-flop.
Hybrid though. Yeah, but it's very cool. I mean, you're obviously using the sub spindle. This
Yeah.
is a Vise screw.
Yeah, this is a screw for our 16-inch Vise.
Yep. So you have right hand, left hand threads.
Yep, exactly.
Cool. And that's a pretty precarious stick out. Are you doing? Is this what happens when it's?
No, actually. So this is a finished part. It's already been cut off. So previously,
Oh, it's just holding for the part.
yeah. So
Cool.
the longest stick out is during this very first operation where it's choked up about right here,
Yep.
and
So
it's a
you
little
do
bit.
axial live tooling to cut the hex.
Yeah, but when we
So-
do that, it's choked up around here.
Okay.
So
Very cool.
yeah, so
You can use the sub spindle as a tailstock.
exactly that's exactly what we do.
Got it.
So and then
So
it's
cool.
just synced. So it's always a little bit hazardous to, especially on this part where there's very little distance here.
Yeah. Holy cow.
And then we're doing left hand threads here and right hand threads here.
Right.
So we're always checking everything to make sure the clearance is right.
It's a dumb question, but you can use the same tool insert or the same tool to cut right and left-hand threads?
You could, but we use topping inserts.
Oh, okay.
Yeah, so we use specific ones from ISCAR.
If you've never used a topping insert, I don't recommend using them because you'll never want to go back.
Yep. Yeah, because this is an ISCAR, so it's a 16 EL. 16 is the size of the insert, 16 is the size of the insert. EL basically means external left-hand thread, 12 National Unified, so I mean 12 TPI. Yep. So this will only cut a left-hand thread at 12 TPI. But basically, rather than cutting to major diameter, we leave it a little bit oversized.
Yeah.
And then the insert takes care of both the crest and the threads. So everything in there is finished in the same insert.
Yeah, it's the full V profile, top and bottom. You're guaranteed.
Right.
That's right.
Exactly. And it simplifies the measuring, at least the superficial measuring. Like we could just take a mic to the threads rather than using thread wire on every single part.
I see.
Now we can kind of selectively choose like every 20th part, and if everything else is in there measures based on a mic, you can kind of predict that it'll work fine.
Interesting. You've got, I don't know that much about lathes, but you've got dual axial line tool in there. That's going, it looks like one's a thread mill?
Yeah, exactly.
So cool.
So like I said, everything here is about process reliability.
Wow.
So on live tooled lathes, if you were using a stationary holder, then tapping's fine. But on an axial, because it's a bevel gear, there's a little bit of backlash.
Yep.
And so I don't deal with backlash when it comes to tapping. It's just accident waiting to happen.
Yep.
And
what gets thread milled on?
Ball couplers.
Gotcha. Okay, different product.
Yeah, different.
So you're able to leave this lathe effectively set up.
Right.
You don't have to do a lot of.
Ever since we got that M140, that actually made a huge difference in the tool setup on this turret. We actually don't even change tools on this turret anymore, like different types. We just change the inserts or the end mills.
It's really nice.
And just to save a little time, we keep collet nuts and collets and tools on standby, cleaned and ready to go. So when it comes time to changing this out, we only have to clean the tool taper and just spin a new one on and touch it off, rather than trying to clean everything again.
Right. And it's got one of those smart arms. Yep.
Yeah. So it's a swing down arm on the main, and then a bolt-on on the sub.
You do have a sub.
Yeah.
That's so cool.
So.
What grinder coolant do you use?
This is still Master Chemical 585, but works pretty well. It's kind of a multi-purpose. See, it's taking off about 1 thou per pass.
Really?
Yep.
You don't hear anything.
Yeah.
Wow. Last but certainly not least, excellent products have to get cleaned.
Yeah, so this one's kind of in the middle of a cleaning fluid changeout. But it's basically an automated
parts washer.
Yeah.
This is the stuff that it's so easy to say, I don't care about that until you realize you need it.
Yeah, exactly. It's got oscillation up and down. It's got heater. It's got a
heater.
Yep. This will take it up to about 160 degrees, 170 degrees. We're still fine tuning exactly how we want to do it, rather than just using the standard degreaser. We found maybe we might use some different, experiment with some different fluids.
So 3 of them that just for
it's kind of the original intent was to have a rough cleaning, a rinse, and then an oiler.
Yep.
So this stuff is just filled with about 60, 70 gallons of CRC 336. Basically the stuff most people buy in 1 gallon, or we bought something like 20 or 30 5-gallon.
And so from here it's ready to assemble and ship out?
Assemble and ship out, wrap, etc. So
awesome.
This really prevents us from having the dip. Really makes sure there's no residual coolant or any water stuck in there.
Yep.
So which is really important, because sometimes just a few drops of water, once it gets wrapped in the paper and the plastic, cause some havoc.
You guys always have done such a good job on the packaging. Every time we've gotten ours, they're really nice. It's like that butcher paper. Yeah. Really tight. I mean, I wish I could wrap my Christmas presents that well.
Yeah, we try to. The paper we use is a VCI corrosion inhibitor. It's a volatile corrosion inhibitors. It's basically is like some chemical impregnated in the paper. It feels a little bit soft, a little bit damp.
Yeah, it does.
But yeah, that's what it does. It just basically inhibits any sort of rust or corrosion.
Right. Very cool. Well, Eric, I gotta say, thank you very much for the tour. Thanks for letting us come in here and film and see how these things are made. Take care.
All right, thanks, John.